Hey, good morning, everybody. This is the Stone Sizzle channel, and today we're going to be talking about equations in quadratic form. So, many equations that you need to solve are not necessarily quadratic equations, but they can be used. They can use the methods that we discussed while solving quadratic equations. Here's our first example. So, if you look at this first example, you might not think, "Oh, I would solve that like a quadratic equation," and you are correct. It is not currently in the form, but it does lend itself to allowing us to do something called U substitution. And that U substitution, you'll hear more about that in calculus, but the U substitution will allow us to get this into a quadratic form so that we can solve it. So what we do first is we do that U substitution. And I'm going to do that by selecting a U. And my U right here, in this case, is going to be this quantity. So it's going to be x plus 1, the quantity of x plus 1 to the 1/3. Now I pick that as my u because in order to have a quadratic, I need a squared. If I square that quantity of u, look what happens. And here I go to square it. When I raise a power to a power, I multiply those exponents. And what do I end up getting? I get the quantity of x plus 1 to the 2/3. So this, in essence, is u squared. This is u. Then we have our minus 2, our constant term, equal to 0. So what I can do is, using this substitution, I can rewrite this equation in quadratic form. So we have u squared minus u minus 2 equals 0. Now if you look at this quadratic form of the equation, we can solve this quite easily using one of our methods. If you were thinking factoring, you would be correct. It is factoring. So we need two numbers and multiply to give us -2, but add to give us a -1 right here. So it's going to be 1 and 2. And it's going to be -2 here and +1. Alright, so then we solve. And we get u plus 1 equals 0. And u minus 2 equals 0. And we find out that our solutions for u is equal to -1 and u is equal to 2. This is not the solutions. These are not the solutions to this equation. We have to do one more step. And that one more step is we have to take our value of u and plug it into our substitution, or substitute in our substitution. So I'm going to take this right here, x plus 1, quantity x plus 1 to the 1/3 equals -1. See what I'm doing there? And we have to do it twice, since there are two solutions to this quadratic. And we solve this now for x. We solve this for x. So what do we do to both sides? We multiply, raise to the power of 3, cube both sides. And I'm left with x plus 1 equals -1 cubed, -1. If I solve that, I get -2 for x. On this side, I solve. It's like our radical equations we learned. We cube both sides. We're left with x plus 1 over here. If you remember, 1/3 raised to the third power gives us 1, so we're left with x plus 1. Over 2 cubed is 8. Subtract 1 from both sides, and we get our x is equal to 7. So here are two solutions to this equation. And what we need to do is, you can take the time and check. Plug or substitute -2 back into the original and 7 back into the original and see if you get a true statement at the end. And I assure you that you will in this case. But take the time if you like and check it. So again, the idea is we are going to take an equation to solve and we try to recognize if it is in quadratic, if we can get it into quadratic form using something called U substitution. And we're going to look at a few more examples right now. Now we're not going to solve these equations, but what I do want to do is help you recognize how we either turn something into a quadratic or if it is in quadratic form. So we look at this one, 12x to the fourth minus 11x squared plus 2 equals 0. Now you might see that this term and this term have a relationship. And what is the relationship? Well, if I take this term and I square it, I'm going to get this term. That helps us with figuring out our substitution. So what can we say? We can say that our u in this case is going to be x squared. So then our u squared is going to be x squared raised to the second power. So we can rewrite this in quadratic form as 12u squared minus 11u plus 2 equal to 0. We can solve this like any other quadratic using one of our methods that we learned. Sorry about that. But just because we have an equation doesn't mean we have to get it in quadratic form. There's another thing that we can do here in order to solve this. And you may have recognized that quite simply we can factor this just the way it is. So if we look at this, we can factor it into two binomials. We can look at the factors of 12 with 3x and 4x. There's only two numbers that multiply to give us 2, 1, and 2. Now you might have to do a little guess and check to find out where the locations of that 2 and 1 go in order to make it work for this equation. But if we check this, 3x times 4x, 12x squared. I'm sorry. I'm glad I just said that. These are squared because 3x squared times 4x squared is 12x to the fourth. The outer will give us 3x squared. The inner will give us 8x squared. Well, we need a negative 11x squared, so we know that these signs are going to have to both be minus. And then we have to multiply that last in order to get that positive 2. So we could have just solved right from here instead of turning it into the quadratic form to solve. Either is a very valuable method and a very viable method for this process. Number 2 looks a little bit more complicated. We have these rational exponents, 1/2 and 1/4. But you may be thinking from the one before that 1/4 and 1/2, sorry about the little straight lines here, my slate is a little sensitive today. You may look at our exponents, 1/4 and 1/2, and recognize that if I squared 1/4, I'm going to get a 1/2. That helps you locate what your u is going to be in this case. So our u is going to be the quantity of x minus 3 to the 1/4, because our u squared is going to be the quantity of x minus 3 to the 1/4 squared. And when I evaluate those exponents, raising a power to a power, I multiply, and I'm going to be left with the quantity x minus 3 to the 2/4 or to the 1/2. So we can rewrite this in our quadratic form as u squared minus 6u plus 8 equal to 0. One thing to keep in mind is when I solve this quadratic in terms of u, we are not finished. We have to still come up with our u, whatever we find for our u, and plug it in here, substitute in here. I have to keep correcting myself there using correct vocabulary, and solve for x. So keep that in mind. We were not done here. I have one more example that I want to show you. And it's this guy right here. Hopefully you see right away that it's a radical equation. And the reason why I'm showing this example is, again, I don't want you to get narrow-minded or think very convergently and think, okay, well now we're doing quadratic form, everything's got to be in quadratic form. Use what you know in your tool belt to solve this. Now you're recognizing right away that it's raised to the 1/4 power. So if you're going to solve this initially, you're going to raise both sides to the 4th power. And look what happens when we do that. Right here, 1/4 to the 4th power, we're going to be left with 5x squared minus 6 equals x to the 4th. Well, I'm going to bring over, by subtracting negative, or subtracting 5x squared from both sides and adding 6 to both sides to get this next step. So I'm kind of skipping this step without actually showing it, but I explained what I did. Now right here we have something with fourth power, something to the second power. You may remember from a previous example in this video, we might be able to get that in quadratic form. First off, can we do anything with this the way it is? Can we factor it? If we can factor it, you can go right on that route and factor it. But if we want to turn it into quadratic, and that's what I'm going to do here because that's what this video is all about, is I'm going to look and say, okay, my u here is going to be x squared, and my u squared is x squared squared. It's going to be x to the fourth. And we can rewrite this as u squared minus 5u plus 6 equal to 0. And again, we can solve this for u. Come back after we have u, make the substitution, and solve for x. So keep that in mind when we're getting equations in quadratic form. I think the most difficult part about this, the new learning part of this, is recognizing and then getting the equation into something in quadratic form. And we'll do some examples in class, but be prepared to discuss and to have good questions for class. All right? Hope you enjoyed this video. And this is Stone Sizzle, out.